Broadway plays and things? Good. Good. Uh, I think spring is coming. Spring rain, spring May flowers, right? April rains.
April showers bring May flowers.
Right, April showers, spring May flowers. Not April yet, but we're close. Okay, good morning. Okay, the first big thing I want to take care of is the original schedule that I gave you. I'd like for you to get it out, if you would, please.
If I had it.
I had that the final exam, at the time when I put this together, the final exam schedule is actually online, and UC determines it. And somewhere between the time that I published this and somewhere they revised it, I guess they realized there was a glitch in it somehow. So when I looked it up this weekend, it's saying that because our class starts at 11:15 on a Monday, that's the first day of the week. It is saying that our exam is on Monday, April 29th, from 9:45 to 11:45. So at the end of the schedule, please change that. It is no longer Tuesday, 4:30. We get to do it a day earlier, which means you get off a day earlier, as long as you don't have other final exams.
Yeah, good thing it wasn't Tuesday.
Is it?
I said, good thing it wasn't.
Okay, good. So it's Monday now, April 29th, 9:45 to 11:45. Yes. Oh, it does say that in the back of the syllabus, but somehow or other, I don't know, my schedule got messed up. Okay, good. So it says it in the syllabus, I guess it's right. So we need to change this on the schedule. And people around you who are missing today, do you mind helping out a little bit and making sure when the people come, either today or the next days, that you tell them, point that out, because that's a really important thing to know. Do all of you have to take the final exam?
Is it only below an 83 or 89?
83. Nice job.
Yes.
What was it?
Nice
93?
job.
I knew it was something.
He said anything what? Above an 83, you said?
Was it 83, 9, or 89 or something? Or?
It was a 93.
Okay.
93, okay. He's trying,
Okay.
right.
Is 83 still a...
That's a B.
Yeah, it's
That's a B.
okay.
A 93 is an A, and then 90 to 92 is an A minus. So the 93 and above cumulative score, be just prior, and you can get some points for your notebooks. And I don't know, they're going to be gigantic, right? Well, you can actually turn in 2 if you need to. A notebook check can get you the extra points. I'm also going to be adding on 20 points at the end because I said that if somebody misses a quiz, I was just going to give everybody 20 extra credit points at the end, which means that if you don't miss any quizzes, you're getting 20 points as if you did miss one. Yes?
Are you giving us like a layout of how you want our binders to be, like whether you want all of the outlines and stuff like that?
Really, I want everything that has to do with material from exam 1 section in exam 1 divider, but I don't care how you arrange it within the divider. But even quizzes and test corrections and all, any handouts and any notes you took, everything should be within that particular area. I prefer that you don't separate out in your binder by tests and quizzes and stuff. That won't get you the full amount of points. And then everything about exam 2 should be in exam 2 section, everything about exam 3 and exam 3. And then of course exam 4, which will be the last exam. This is the 3rd exam that we're taking next Wednesday. And then there's only one more exam, and that's on the human body, which is our last part. So this exam next Wednesday, not this Wednesday, but a week from Wednesday, is over all the zoology and the 2 chapters on ecology. Okay. So if people want to start making up potential test questions, you can do that again as usual, and I will gladly take them from, I'd really like to have them by Friday if at all possible. Give me a hard copy by Friday, because I plan on making up a test probably over the weekend. I hope, barring any unforeseen circumstances. So, all right. Also, I'm sorry, in addition to zoology, we also studied viruses. We started out with viruses, then we went to the zoology sections. Oh, yeah. Yeah. Okay, today we'll do any brush up we need to do with vertebrates, and then we were going to go on to chapter 55. This is March 25th. Chapter 55, Ecosystems and Restoration Ecology. And let's see, who did that outline? You turned it in early, I know. Okay, thank you, great, yes. Okay. I need to find that. Any other questions? Before we go on? You did, everybody get a handout? You have 2 sides to it? Actually, probably what I would do is have this as the front side. Pretty much. You should things like and we had those students volunteer to be human to be dissected, so we're going to dissect a rat, and so that kind of goes along with that.
I don't want to keep our lives, so.
Malaga, I'm sorry, this got cut off some. This is a lag more. And I forget what page it's on, but you could find it.
given you a bunch of other stuff too, I know. Okay, I'm sorry, I'm looking for my outlines for 55 and 56. Okay, Grace did 55, and then Brittany Barnes did 56. So Grace is back there. Brittany, where are you? Brittany's over there, so Brittany Barnes and Grace are ecology experts for this section. Could we also, remember this I gave you? The vertebrate chart? Could you also get that out too, please? Okay, so you'll have this. Now, I should use duck sand, shouldn't I? Probably should use a duck.
You sit in that chair, it's all the sit in that chair,
Yeah. First of all, what are the characteristics of all chordates? Somebody over here who wants it. What are the characteristics that all chordates have in common? Anybody want it? Ava, you want it?
Don't they have like, group core or something on the side?
Okay, so they have a, on the ventral or dorsal? Dorsal? Yeah, the dorsal side. So yeah, I want to repeat what you said. A dorsal nerve cord running down the back. Somebody from this section, what do you think? What's another one? Aaron? Yes, it is. It's still in the dorsal area, but it's central to the spinal cord. And over here, there's another characteristic that also have in common. Last one. Eric? Right. Pharyngeal gill slits sometime in their life. So I would know those four. The dorsal nerve cord, the dorsal notochord, which is like a pharyngeal yoke split, or pharyngeal splits, and the post-anal tail. So, there are two subphylum, and a subphylum is sort of like the black they're a half step, either sharp or flat, to the regular notes. So a sub is like a half step below the phylum. So subphylum, I don't know if it is or not. I can see some similarity. But the third subphylum of Chordata, of the phylum Chordata, is the subphylum Vertebrata. Now it turns blue. So everything, the reason why I left, I did this a 3-column method, and I left the middle there for your notes. That you can take notes either from the left or the right and kind of have a nice study page. So the subphylum Vertebrata are the vertebrates. And the first class is Cyclostomata, also called agnatha. A gnath is jaw. And if you put an A in front of a word, whether it's asexual or sexual, or biotic and abiotic, or anaerobic and aerobic, A-N-A-N, it means the opposite. So agnatha means no jaw, and the actual mouth is a round mouth. So it's called also cyclostomata. The opening is a stoma. And these are the lampreys and the hagfish. And I would probably put more emphasis on the lampreys. We kind of know more history in some way to talk about. But remember, they're external parasites, and they disrupted the fishing industry in the Great Lakes. Then we kind of do a clad thing here. This is not really a class, but this is a clad that's thrown in the Gnathostomatas. And a Gnathostomatas have jaws. So everything else below here has jaws, including the third column. Okay, then the class Osteichthyes is what I'm going to call it. This is osteo means bone. Okay, so bony. I miss chondrichthyes somewhere. Oh no. Okay. I messed up. Will you ever forgive me? There's a class we messed up, chondrichthyes, and chondrichthyes means cartilage, and they do have jaws, because we know that jaws
Sharks are made of
are
cartilage.
sharks, they're more ventral, slitty mouths with their terrible teeth for ripping flesh that are like the scales. So class chondrichthyes should be first. So those are the sharks, rays, and skates. Then the class Osteichthyes, bony fish, And then I just put the low fin fish in there too, the coelacanths. Perch. Most of your fish that most people go fishing for are usually ray fin fish. They have stiff spines in their fins. And perch, walleyes, all kinds of bass, bluegills. So then if we go back to this. So with a cyclostomata, walleye, lamprey, external parasite. What does ectothermic mean?
Cold-blooded.
Cold-blooded, thank you. So there are also another word you might run into sometimes. Called poiky. I love to say that word. Poikilothermic. That means cold-blooded too. They're aesthetic. Then these then become the gnathostomes. At least I have chondrichthyes on this one. Gray skates, cartilaginous skeletons, so that's what I would remember. I also remember about their scales. Homologous, 2 teeth. And also it probably say something about the teeth. Go from posterior to forward to anterior. You have rows of teeth, and if they lose one in the front, there's another row right behind it to pop up and to pop into place, so that they can constantly be their predator thing. I'm talking about the real bad sharks that are always, predating on their prey. They're also cold-blooded. Then the osteichthyes. So what did we say ichthyology is?
Study of fish.
Study of fish. So it's a branch of zoology that studies fish. It's like in lab today, we talked about the branch of zoology that studies insects, or entomologists, ENT, entomology. Yeah. Oh, yes, ichthyology. Ick. Ichthyology is the study of fish. This whole thing is zoology. Up. The bony fish are like the first group of vertebrates that we're going to really talk about in a little bit more detail. And we also will be dissecting a perch. So they're respiratory, they have gills. The whole cover name is called the operculum. One of the things that they also have, in fact, the lateral line, I believe, is also present in chondrichthyes. The lateral line is a row of pitted scales along the side of the fish
that detects what? What is it? Motion, yes. So motion, and it helps them to save their lives. You know, they go away from where there's a lot of motion, or depending on how they feed, might go towards something like a shark, a predatory shark that we need to be careful of. You don't want to splash, because they're drawn to splashing, and if you cut yourself, blood, they can sense blood for long distances in the water. And so blood and splashing, and no matter how people swim, even the best swimmers, they still don't swim as well as most animals that were made to swim in the water all the time. So there's more splashing involved, so they can be drawn towards the splashing. The lateral line is a sensory that helps them, so that would be more with the nervous, it's almost part of the nervous system. Let's start focusing on the heart. It has one atrium and one ventricle. Some of the older versions and some diagrams that you may see, they'll say auricles. That's a very old terminology used. Auricles, they're the same as atrium. So just kind of know that those are the same. So one atrium, one ventricle. Lesser evolved situation than a closed system to be more efficient. Fertilization, okay, now you're always going to find exceptions for certain species, but in general, this is what I'm going to say. External, we've already talked about the inefficiency of external fertilization, the need to lay lots of eggs in order to have any fertilization. So we talked about that. They're also cold-blooded for the most part. Again, there might be a few exceptions. Any different questions about osseous beaks? Okay, let's go. Let's climb out of the water. We're the first group to come on land for any reasonable amount of time. However, if I'm an amphibian, it's likely that I'm still tied to water in terms of reproducing, because my reproduction is still external, and you need water medium in order to swim the swimming sperm to do their thing. So amphibians, and that means 2 lives, half water, land. Which one of these did I say is the most terrestrial? Land. Frog toads are found there. So,
about us here in this area in particular, you may have some variation elsewhere, but toads tend to be a little more, they can tend to be a little more dry, whereas the frog is more streamlined. Its skin is going to have to be moist because it does a lot of its breathing in the skin. And it just hangs out around water a lot more. The toad can get away from water further, but when it needs to reproduce, it has to find a body of water in order to lay its eggs in. I used to know this, somebody probably knows it. Toad eggs versus frog eggs from around here. One lays them in strings, and one lays them in clumps. And I forget which is which. But I guess there is a way with eggs that you can tell whether they're going to be toads or frogs. Salamanders, of course, salamanders and lizards have similar bodies. They have a long tail, they have 4 legs, and they have a more slender body. The lizards are reptiles. They have dry, scaly skin. The salamander has moist, thin skin. You have to have, if the skin's going to be respiratory, any type of respiratory disease, then it's going to have to be cold, it's going to have to be moist in order to exchange carbon dioxide and oxygen through the skin. They have a 3-chambered heart. They actually have 2 atria, plural atrium, and 1 ventricle. Internal. Which word? Remember anaphylaxis? Where they position themselves right on top of where the eggs are, and so they could directly fertilize right over top. It's much more efficient than the way the fish do it. Okay, so we're increasing complexity here, and a 3-chambered heart is more complex. But it's still not perfect. If we're designing reptiles, this is actually claim to fame the first true land vertebrate. No longer has to be tied to water to reproduce because of this amniotic egg, and that is one of the most major developments for terrestrial way of life. That actually has like a shell on the outside, and it has a series of different membranes that serve different functions on the inside, and they have yolk, they have a food source, the embryo develops inside, it can be left on land, and it will hatch out of the egg. Not moist eggs like the amphibians have, that have to stay moist. They don't have a true shell on them. So this is the first development. If you go this way, because that's really what we're doing here, is with increasing complexity, you're seeing that we actually, it's the first group to have true lungs, to breathe truly with lungs. And, okay, this, I don't know that you're going to find that in your textbook, but just because I've done a lot of zoology teaching before, I've always sort of said it's a 3.5-chambered heart, which means that it's a little more divided than the 3-chambered heart, but it's not yet a 4-chambered heart. So it's a 3+ divided heart. So I'm going to say it's a 3.5-chambered heart. Internal fertilization, there's a big gain. More efficiency, you don't have to lay as many eggs, you're more sure that more are going to be produced. By the way, over here, this is still full-blooded. And this is still full-blooded. hypothermic or poikilothermic, cold-blooded. So here's something that we might need, to look for advancements in. Okay, please understand this though. Reptiles, even though they're most, you might find just a few examples of reptiles that technically have some ability internally to correct some of their temperature changes, but for the majority of the group, they're still considered to be cold-blooded. But reptiles have one of the most adaptive, efficient ways of coping with being cold-blooded, and that is through changing their behavior. They know that if they're cold, they go find a rock somewhere and let the sun hit them on this rock. Yeah, they sun themselves on the rocks. And they know when it's really hot to go bury down under stuff to help find shade to protect themselves. What it means to be cold-blooded is that the temperature of the body is approximately that of the environment. So if we had a snake in here on purpose, if we had a snake in here without any heat lamps or anything, and I would say the temperature in here, if we do Fahrenheit, is probably around, 72 degrees, 70, 72 degrees. Probably low 20s Celsius. Its body temperature, if you could take it, would be approximately, as long as it's been here long enough to adapt to this temperature, it would be approximately the same temperature. That's what it means. When I first started teaching many moons ago, at the high school level, we used to have a boa constrictor named Wadsworth. And Wadsworth was almost like a school mascot. And he got to be approximately 6 to 7 feet long, a boa constrictor. And the other biology teacher who really owned him was really into herpetology, which is the study of reptiles. Some people will also add amphibians in that too, but when I think of a herpetologist, I usually think of a reptile person. But anyway, in the wintertime, Wadsworth was easy to handle. Because the room temperature, like I said, would be about like this. And he was, you could get him out and you could pass him around and he'd get around in your neck and you'd hold him. And this is, how many of you are going to be teachers? No, I thought some of you maybe were. But anyway, the thing is that coming out of my bachelor's program with a teaching certificate and loving nature and loving the farm and loving biology, when I was so scared to death of snakes. I really was. And of course I had to learn in front of my students because I had to do it. I had to learn how to hold the snake, and it really wasn't as bad as what I thought. And I got to be much better. So just to tell you that you may think you're scared of snakes and that you don't want to handle them, they're really not that bad. As long as you know what you're doing and it's not a real aggressive snake.
Have you ever learned how to properly capture an aggressive wild snake
No.
relocating?
No.
How you have to pin its head and
Yeah.
grab it by the heads that won't bite you? And
Right, I've never attempted to do that. I've chased a few off, but no. But the story that I wanted to tell you that's related to cold-bloodedness. Oh, there's a python. Yes, and of course I hated it when we would feed him because you put in live mice and rats and I hate that. The whole thing. In the summertime, I would go in to the room and do something. schools out. But anyway, I would go into the classroom where Wadsworth was, and I would walk past his cage, and he would go, I mean, he was striking at me. He was, because this particular school had no air conditioning. And so his poor body temperature had to be in the 90s, 80s and 90s. And when the thing with metabolism is when it's raised to that high a temperature, they need more food in order to keep up that rate, and they're aggressive. They get aggressive when they're hot like that. But when they're cold, they're just kind of lethargic and laid back. So beware with cold-blooded animals. It can be a variable to watch for. So. '80s is a separate class. Even though the phylogeneticists, and please remember this, there can be some questions on the test coming up that will maybe start with, from a phylogeneticist view, versus classic taxonomy that has the 80s in a separate group. If I ask you from a phylogeneticist view, what do you think? Are birds reptiles?
Yes.
Yes. From a phylogeneticist view, yes. But from a classical taxonomy view, we can just put them in a separate group and say, okay, so we're going to put their glorified reptiles. They have the characteristic dry, scaly skin. And that dry, scaly skin has been adapted, modified into feathers as their integumentary system, which is their outer body coverings, into feathers. Who really are the true inventors of the airplane? And this is not a good time to talk about airplanes, I know that.
Wright brothers.
Now, before the Wright brothers. The birds. Now, they didn't physically make them, but how do you think the Wright brothers got their ideas? Yeah, and then watching birds and how they're built. Watching a bird fly. The lift and you want something that's really light to be able to get off the ground, and the feathers. Look at the wings of look at the airplane, the classic airplane. You've got the nose that's kind of like this in the most part, which is like a bird when it's flying. You've got so aerodynamically, you've got wings. You make an airplane out of something that's lightweight. You don't make it out of the heaviest steel and things like that. Birds. Flightless birds, but if we assume that most birds fly. Do chickens really fly?
Little
They glide.
sparse, but not
They
much.
glide.
Yeah, not really true flight, it's just kind of a little glide. They could get off the ground a little bit, but not really true flight. They have, in order to fly, okay, what activity that any animal does do you think requires the most energy?
Probably like moving their muscles around a lot.
Right. I mean, have you ever tried? you can't even get off the ground, but if you have to do this all the time.
That's a good arm workout.
I mean, flying is a very costly means of locomotion, which means that birds have to have a very high and a very efficient metabolism. The way in which they process food and get the energy from food through cellular respiration and that whole works. Okay, so they have a very highly efficient, and they also have no, we're not going to get to the intelligence thing. But two atrium, two ventricles. What's the great about a four-chamber heart? Okay, you've got an atrium, ventricle, a ventricle, and you've got a septum in the middle. It's like a divider of the nervous system. What's such a big deal about a four-chambered heart?
One side's for oxygen, one side's for the oxygen.
Okay, say it nice and loud.
One side's for the oxygenated blood and the other side's for the deoxygenated.
Perfect. You don't have a mixing of the oxygenated and deoxygenated blood. You have it separated. And so birds and mammals are the only groups that have that situation. And also are able to have endothermic control within a range. Control body temperature. Here's a little trivia. Now, when you say right and left, you have to think as though it's in your body. So, this is my right side. This is my left side, right? Although you're looking at me in the left. It must, for some reason, help the birds have it swing that direction. Endothermic, internal fertilization, of course. Okay. Yes.
How is it internal?
I'm glad you're asking this. I was about to okay. Finish the rest of your question. And nothing stupid. Okay. Don't worry about it. Just
Yeah, that
ask.
just doesn't make any sense to me, but they're wild eggs, so that's outside.
Okay. Beautiful point, and I'm so glad you said that. If you raise chickens for eggs, and then you buy the eggs, do you want fertilized eggs to eat?
No.
No. I don't want to open my egg and find an embryo. I really don't.
I think that's happened
It
several
has.
times.
Oh, it has. It does happen.
It happened on a culinary show once.
Okay, so how does the egg producer make sure that they're not fertilized eggs? Candling, my dad used to do that when he was in high school to make some money, candle eggs.
I know with our barn, we sometimes, if the hens and roosters even get close in the same cage, like they can be separated, but even if they're close, risk that, so we have to put it on like opposite sides.
Who do you have to keep away? The rooster! Okay, so here's the way it is. They have to do it before the eggs are laid. So right now, the spring of the year, you're seeing robins and other birds starting. They do that funny little
fluttering around, and then finally one will, the other one, and they'll go on. They're rubbing their cloacas together. They have a common opening. Remember we talked about the common opening of birds? That reproductive products, digestive products, and excretory urinary products come out of the same opening. But during fertilization and during reproduction, it's only the eggs and the sperm. So there's no penis involved in the male. It is just the common opening cloaca and the common opening of the female, and they rub them together and the sperm come out through the cloaca into, when they rub it together, and so the sperm come out, and that's how they get fertilized. So you keep the rooster away from chickens that you want to keep just for egg production, for people to eat eggs. Because if the rooster gets a hold of the chicken, then you're gonna end up with fertilized eggs. So the reproduction has to be before it's internal, but birds will, like chickens, will still lay eggs even though they haven't been with the rooster. Well, if you think of it, people still lay eggs too without laying eggs. You know what I mean. We ovulate, females ovulate during egg producing years, one egg approximately a month. It doesn't come out of our body so that we see it, but there is an egg usually that's released, so it's kind of the same principles. But some of these are things we just don't think about. But it's good for us to know those important things. It's great dinner time conversation. Did you know? Great dinner time conversation. And so mammals of the highest level, and we've got all that's there, and then I also want you to study and look at all the different groupings of mammals and study those. And if you have any other questions, bring them. We are going to do chapter 35 or 55